So we begin with a straight line, and in this first lecture we're going to be looking at three concepts: distance formula, midpoint theorem, and the gradient. Now, first of all, the distance between 2 points. We'll start by looking at points on horizontal and vertical lines, which is a very straightforward case, and then develop to a more general distance formula for the distance between any 2 points. So let's begin by looking at this graph here, where we have a line between 2 points x1, y1, x2, y2, and the line is parallel to the x-axis. So it's parallel to the x-axis, y1 equals y2, and hopefully it's straightforward enough to see that the distance between those 2 points is just the difference in the x-axis. So distance is just x2 minus x1, x2 minus x1. Now in the case of a vertical line, again it's fairly straightforward. Here we have a vertical line. In this case, x coordinates are going to be the same. x2 is going to equal x1, and in this case the distance is going to be given by the difference in the y coordinates. y2 minus y1 will give us the distance d of this line, or between these points. Now, just to make sure we're following that, stop the playback here and try this one for yourself. So stop that and try this one, and then restart, and we'll do it together. Okay, so here's what you should have got. Since both y coordinates are minus 3, actually the distance is the difference in the x coordinates. So this line is a vertical line, and it's just 16 minus minus 7. Taking account of the minuses, we end up with 16 plus 7, 23 units. Now let's generalize that. The distance formula will give us a method of working out the distance between any 2 points, and it's based on Pythagoras theorem. So here we have now a line that's not horizontal or vertical, just a line joining 2 points x1, y1, x2, y2, and by constructing a right angled triangle with lines parallel to the x and y axis, and using what we've developed above, then what we can do is use Pythagoras to say that the distance between these 2 points is just going to be the difference in the x coordinates, x2 minus x1 all squared, plus the difference in the y coordinates all squared, and take the square root. So it's just d squared equals this side squared plus this side squared, Pythagoras. Now I've said up here this is to be memorized. There are a number of formulae through the course, obviously, that aren't given in the exam, and you've got to know them and be able to use them. So this is the distance formula. So again, here's an example. Stop the playback and have a go at this one now, just to make sure you've understood that. Okay, there's the distance formula that you should have used. The difference in x, the difference in the x is squared plus the difference in the y square rooted, and there's the working out that you should have got there. We've got the difference in the x's is 3 and minus 2. Again, look at this, take care with the signs, and you end up with 25 plus 9, square root of 34. Now the next thing we're going to consider is the midpoint formula. The point halfway between 2 points, not surprisingly, is called the midpoint. And again, it's straightforward enough to calculate this. the midpoint between the midpoint of x1, y1 and x2, y2 is just the sum of the points over the sum of the x coordinates over 2 gives you the x coordinate of the midpoint, and the sum of the two y coordinates divided by 2 gives you the y coordinate. So if you like, it's just averaging. It may be helpful to think of the midpoint as the average of the 2 points. Again, this is a formula you should memorize, and again we'll have a look at an example here just to make sure you've got it. So again, pause the tape and try this. Okay, there's the answer there. There's the midpoint formula. You just add the x's. So we've got the x coordinates 1 and 7. We add those and divide by 2 gives us 4. Y coordinates minus 4 and 8. 8 plus minus 4 gives us 4 over 2, and that's 2. Now here's another example to try, slightly trickier. Have a go at this one again. Pause the playback and have a go at this. So this one here, we see that C is the centre of the circle and AB is the diameter. So this time we're given the centre coordinate 17, 12. So the midpoint formula, what we do is we say the one we're looking for, B, we give that coordinates x and y, and we can say that the midpoint 17, 12 is 9 plus x, because 9 is the x coordinate of A, and x is the x coordinate B, so 9 plus x over 2 gives us the 17, and minus 2 plus y over 2 is going to give us 12. And then what we do there is just set up two equations saying that the x coordinate 9 plus x over 2 is 17. That gives us this little equation which we can solve, hopefully, to get x equals 25. And the y coordinate equals 12, and we get y equals 26. Now, let's go on to consider the next concept, which is the idea of gradient, which hopefully you've come across before. Now, consider a straight line passing through x1, y1, x2, y2. And the gradient of that line is given by y2 over y1 divided by x2 minus x1. So it's the vertical distance you've travelled going from x1, y1 to x2, y2 over the horizontal distance. So that's the horizontal, that's the vertical. It's the vertical over the horizontal. Again, you've got to remember that, and the gradient, which is usually written as m, change in vertical over change in horizontal, is the difference in the y coordinates, y2 minus y1, over the difference in the x coordinates, x2 minus x1. We'll come back to this part here later. So, another way of looking at that is presented in this slide here, and that is that this y2 minus y1 over x2 minus x1 is also the definition of tan theta here. So another way of expressing the gradient of this line is to say that the gradient m equals the tan of the angle the line makes with the positive x direction. So it's from here round to the angle is theta. And again, that's another formula to memorise and use in the higher maths course. So as a result of the above, we've got some further general points to make before we start to use these formulae, and that is that a line with a positive gradient slopes up from left to right. So this is positive gradient because the change in y is positive. This one will have a negative gradient. A line going downhill like this will have a negative gradient because you've moved down on the y-axis, if you like, moving from here to here. And the other 2 points are lines parallel to the x-axis have a gradient of 0 because there's been no change in the y. y2 minus y1 is 0. So 0 divided by anything is 0. So the gradient of this line is 0. And the gradient of a vertical line is said to be undefined because there's been no change in the x coordinates, so you would be dividing by 0, which you can't do in maths. So we say lines parallel to the y-axis have an undefined gradient. You will also use the fact, as it says here, that parallel lines have the same gradient. So the gradient of parallel lines is the same. Now here's an example. Stop the playback and try this one here. So there it is there, it's straightforward. We know this angle that the line makes with the positive x-axis is 32 degrees. So m equals tan theta equals tan 32, which is 0.62. So the gradient of this line is 0.62. Here's another example. Again, stop the playback and try this one. In this case, we're using the formula, the difference in the y coordinates over the difference in the x. So it's 7 minus minus 2, which is where we get this plus from. And it's 1 minus minus 2 for the x's, which is where we get this plus minus minus 2. So we get 9 over 3, which is 3. So m equals tan theta. So therefore, in this case, as the gradient's 3, tan theta equals 3. So the angle will be the inverse tan to the minus 1 of 3, which is 71.57 degrees. Now, here's another example to try. Find the size of the angle theta shown in the diagram below. So try that one. And here's the answer. As it says here, we need to be careful because that theta isn't the theta of m equals tan theta. Theta of m equals tan theta, the angle that the line makes with the positive x-axis is this angle here, A, which is the same as this one, if you like, it's corresponding angle. So when we find A by saying A is tan to the minus 1 of 5, because we're told the gradient is 5, we get A is 78.69, so theta obviously is 90 minus A, 11.31. Hopefully you got that. And that ends the first presentation on straight lines.